Hey everyone, and welcome to a new video on this channel. It's been a while since my last video. Life's been busy, but in this one we are going to show how to write a simple application that does something useful. In this case, it generates tweets using the Azure OpenAI services, and we're going to show how to deploy this fully to Azure Container Apps and showing some of Azure Container Apps features in the meantime. Before we get started showing the different components and building blocks, let's take a quick look at the application itself. The application generates tweets about a topic that you select. For example, suppose you want to have a funny tweet about Kubernetes, if such a thing is even possible, and you just fill in the text and select the sentiment, and you click the submit button. Then you get the tweet that looks like this, and I'll let you decide if this is funny or not. You can also select a different sentiment. For example, I want to have a serious tweet about Kubernetes. Then we're getting something that looks like this here. So that's the application. Now, in the backend, the actual tweet is generated by a OpenAI model. We are using the text DaVinci 003 model, and we're using the Azure OpenAI service for that. And later I'll show you quickly what that looks like in the backend. Let's look at what we're going to build here. So we're first going to deploy a container app environment. And within that container app environment, we're going to deploy two container apps. One application will be the web UI, which will be protected by Azure Active Directory. The web UI container app has a managed identity. It is used to grab the container image from Azure Container Registry, which is a private registry, so we have to authenticate to it. The application is also using Dapr because the web UI is going to make a call to our API here that is using the Dapr invoke APIs. I will explain how to enable that and how that works. The API also has a managed identity. It's the same identity of the web UI. And with that identity, we are again pulling our container image from Azure Container Registry, but we're also reading a secret from Azure Key Vault. The secret we are going to retrieve is used to actually authenticate to Azure OpenAI service. That's just one of the ways to authenticate, because the API is going to call the text DaVinci 003 model to generate a tweet. I have already mentioned terms like container apps and container apps environments, but what is container apps really? Well, Azure Container Apps is a serverless containers as a service solution optimized to deploy microservices. It's a containers as a service solution, which means it allows you to focus on the applications and not the infrastructure. And when you deploy Kubernetes, there's still quite some infrastructure stuff that you have to do. It is also serverless in the sense that it allows you to scale dynamically based on events, and it also allows you to scale to zero. So if a container has no work to do, it can be scaled to zero and you do not pay for that container. Now, instead of building this solution completely from scratch, Microsoft decided to build container apps on open source technology. So under the hood, although you don't see it, there's still Kubernetes. Your containers run on a Kubernetes cluster. For scaling, Kera is used, the Kubernetes event-driven autoscaler. If you want to make distributed applications microservices applications, you can use Dapr to make your life somewhat easier. Dapr is optional, but highly recommended in many cases. And for networking, Microsoft uses Envoy under the hood. Before you can deploy your first container app, you need a container apps environment, and that gives you access to this AKS, this Kubernetes under the hood. Now, a container apps environment is free. You only pay for the container apps running within the environment. Now, I must admit it's not entirely free because we also need logging. The logs from our containers and from the environment itself can be sent, that's an option though, to log analytics. And of course, that consumes storage space and you'll have to pay for those logs to be stored. Now, by default, a container apps environment has a public IP and public endpoints. You can optionally though connect your container apps environment at deployment time to a virtual network. That will allow you to make these container apps available on the internal network using private IPs. In my example, in our demo, we will use the public environment. Now, when we are going to deploy the web UI and the API, as previously discussed, we will have to deploy container apps. So when I deploy my container app, the web UI, the first time, I'll get a container app, but I'll also get a first revision, a first version of my deployed application. And my actual web UI container will run in a replica. And you can compare a replica to a pod on Kubernetes. In fact, that's actually what it is. And depending on scaling rules that we set, I will get one or more replicas within that revision. Now, if I deploy a new version of my web UI because it has changed for some reason, then I will get a second revision or a second version of my web UI. And in the default single revision mode, that second revision will become the active revision, receiving 100% of traffic. Of course, in our case, we are going to deploy a second container app, which works, of course, in the same way as the first one. In our case, the container app 2 will be our API. And that API is going to call the Azure OpenAI service when I generate a tweet from the web UI. Container app 1 and 2, in our case, will communicate over an internal network, and we will use Dapper to do so. And we'll see how that works later. Before we dive into details, know that everything I'm talking about, including all the code, is available on GitHub. Just go to github.com/gbake and then find the ACA-OpenAI repository. We are going to deploy all components using Bicep and infrastructure as code. So you do need some knowledge of Bicep before understanding this. I have a couple of videos of Bicep on my channel if you're interested. Now let's take a look at what we are deploying from this Bicep file. The first thing we are going to deploy is an Azure Container Registry, as you can see here. And the container registry will be named according to the prefix that we set here in par prefix, and then ACR, and then a unique string, because we need a unique string, a unique URL for the container registry. I'm using admin user enabled, which allows me to connect to my container registry using a username and password. I need that in my GitHub workflows that actually build the UI and the applications. I'm also deploying a key vault. If you remember from the diagram we showed, the key vault is used to store the OpenAPI secrets or keys. So we deploy the key vault and we also add secrets for these keys. Now my backend API is flexible enough to either use Azure OpenAI or the OpenAI APIs directly. So you can add the two keys for both environments to Azure Key Vault. And the code of the API will retrieve this key, this secret, at runtime, depending on how it's configured. We also need identities. Remember, I talked about managed identities for both of my container apps. Well, that managed identity is created here. It's a user-assigned identity created in the same resource group. Now, of course, that identity needs access to Key Vault. So we're gonna grant a role to that user-assigned identity, and the role will be the role of secrets reader. Now, these roles actually are identified by GWTs, and you find those in the following URL that you see here. What we also do is use the same technique to assign the role to pull images from our Azure Container Registry. Again, there's a different GWT for that role available. Then we can go and start deploy our Container Apps environment. Now we want to have a Log Analytics workspace because we want to connect our environment to Log Analytics, and we create a separate workspace for that here in this part. Next, I also connect application insights to my Container Apps environment. Although I'm not using it in this demo, it is deployed when you run main.bicep. And then we get to the actual deployment of the Container Apps environment. And that's as simple as doing this resource deployment here. So we just say we want a managed environment. We want to deploy it in this location, which will be West Europe by default in my case. And we also have the optional log analytics configuration. That means we're sending the log files from our containers and from the environment to the log analytics workspace that we just created a few steps before. What I also do is I have automatic logging set up from Dapper to Application Insights by using this configuration here. With the Container Apps environment deployed, we can now actually deploy the Container app. So remember, the web UI is going to present us with that simple tweet generator interface with that submit button to generate the tweet. To create that Container app, we're going to create a resource of this type over here, and all the things we talked about in the diagram are configured. For example, we are assigning an identity to this Container app, and we're using the user assigned identity that we just created a few lines above in this file. We are going to link the Container app to the environment that we just created, and the Container app will use the single revision mode. That means that when I deploy a new Container app, that one becomes the active one and receives 100% of traffic. Because this UI container is going to use Dapper to call the backend API, I have to set Dapper enabled to true. And Dapper also needs an ID for each Dapper application. You just select a name that you like to use. It doesn't have to be the same name as the container. Now this UI is going to be made available on the internet using a public IP. So I set the ingress external setting to true. That will configure Envoy as a reverse proxy. And of course, that also means that Envoy needs to know what my container itself is using as a port. What's the target port? I was a bit lazy here, and I'm using port 5000 of the Flask development server. That's fine for a demo. In production, you normally wouldn't do that, and I'm just using that here. Remember, we're also going to use Azure Container Registry to pull our images, but that means we have to tell Azure Container Apps, we have to tell what the login server is, and we also have to specify how to authenticate to ACR because it's a private registry server, and we are using again the identity that we created earlier. Now, what the actual deployment is concerned is of course here. What container are we going to deploy? That's in our template. And there are two parts in here, an array of containers, but we only have one container deployed, and then the scale of our containers. I'm gonna just start with a minimum replicas and max replicas set to 1. So we always run one instance of our web UI application. And the most important part is of course the image we are going to use. Here I'm referring to an image in my ACR. Now there's a bit of a chicken and egg situation here because we deploy ACR here in this main.bicep. So at first deployment time, this will of course give you an error. I will show how to fix that in a moment. Now this web UI needs to know where the backend API is, how to actually call the generate method, because the API implements one method, which is the generate method, how to call that. And because we're using Dapper, Dapper runs locally on our system. That means that my Python code will actually do a request to this URL. So it'll talk to localhost 3500, which is my Dapper application running in the same replica as my main application. And we're using the Dapper invoke API. So we have to specify v1.0, then use the invoke API, and then use the Dapper ID of the API, the backend that we have. And I'll show you this already. If you go down a bit where we deploy the API, you can see that Dapper was enabled and we have called that Dapper instance. The Dapper ID is OpenAI. So that means that indeed it knows where to send the call to. And we also tell Dapper to call the method, the HTTP endpoint called generate, which is implemented by that backend API that we created in Python as well. And we just give this in this case as an environment variable because we didn't want to hard code it in the Python UI application. The deployment of the API is of course very similar. It also uses this identity, so we have seen already how that works. We have the single revision mode. Of course, the Dapper ID is different, as was just explained. And we don't want to have an ingress. The external ingress should be false, but there should be an ingress configured internally, and this makes that happen. There will be an internal ingress. That means that my UI can talk to the API over the internal Container Apps environment, so to speak. Again, we need to specify the login server credentials for ACR, and then the template is very similar to the Web UI template. But of course, because our API is or can be configured to work with different OpenAI APIs, for example, the Azure one or the default one from OpenAI, I have a type parameter there. I'll discuss that later, how that works. Because we also need to retrieve something from Key Vault, we give it the Key Vault URL. And because we are going to use the managed identity assigned to our container app to connect to Key Vault, our code needs to have the client ID of the managed identity we just created. So we create an environment variable here that sets this client ID, so my code can read it and then can use that to retrieve the Key Vault secrets using that managed identity. And for scale, we just use 1.1 as well. If you go to my GitHub repo, or you forked the repo, which is of course better, so you can work in your own repo, you'll find a README file in there. And there's a topic which is called Create Container Images for First Deployment. I talked about this chicken and egg problem where we deploy main bicep the first time, we create an ACR, and there are no images in ACR. So what you can do, this is just one way to solve it, is to just have a Docker account, log into Docker Hub with Docker login, and then do the Docker build and push commands for both the Web UI and the OpenAI. And then in main bicep, what you can do is just replace the references to the ACR images, replace them with references to the Docker images. And then you can proceed to deploy your application the first time. Now, of course, the infrastructure deployment the first time, you also have to still do that. That you find in the same README MD in the deploy infrastructure section. The only thing you have to do is set a few variables, and these are for a bash shell, where you can set the resource group, the location in Azure, the prefix for your resources, and then both the Azure OpenAI key or an OpenAI key you get from OpenAI directly, and I'll talk about that in a moment. And then you just use the basic Azure CLI commands to create a resource group and then to do the deployment with Bicep. So when you've done the Docker stuff before, you modify the references and you run these commands, you should have your container app environment, your Key Vault, and your container apps deployed properly in your Azure environment. But of course, where do we get these API keys from? To use Azure OpenAI, you have to go to Cognitive Services and create an Azure OpenAI service. Now, the first time that you do that, you might not be allowed to do so because you have to fill out a questionnaire and specify the reasons why you would like to use Azure OpenAI. Once you filled in that questionnaire and you're approved, then you'll be able to create these kind of services. I did that and I created this OA-GEBA OpenAI service. When I click on this, what you'll see keys and endpoints. So here I see, for example, the endpoint I have to use to do the calls. So I will need this to generate the tweets. And here, I won't show the keys, of course. You can actually copy the first or second key and use key rotation and so on to get the Azure OpenAI key for use in your deployment. If you cannot use Azure OpenAI or you're not approved for some reason, you can get a paying account at OpenAI directly. So I have an account on OpenAI as well. And once you have that, you'll find in the dashboard that you'll get in the menu here, you'll find View API Keys. And from there, you can create your own API key for use again during the deployment we talked about earlier. After running your main.bicep successfully, hopefully with the 2 API keys, or maybe just one of the API keys, you should then have your Container Apps environment. You can find them in the portal. I have multiple ones here, but the one I just deployed is this one here. It's the AI ACA environment. So this environment looks a bit like this. What you see here is that it's very simple. There's not much to configure here. The only thing we can see is that we have our logging options configured. We are using Log Analytics, as you can see there, and you can go to Log Analytics directly using the Logs menu. Now, if you just want to see the latest logs, they added a log stream option for the environment. So if you click on log stream, what you'll see is indeed the latest logs of what happened at a system level, not at a container app level, but as a system level. What you do at the environment level is set up things like certificates for custom domains or even a custom DNS suffix, which is in preview. I'm not using that, so what I'm going to use is the default DNS names that a Container Apps environment is giving me. Now let's take a look at the apps we deployed. So if you deployed your main.bicep and you also switched the container image references to the ones that you build and put on Docker Hub, you should see these 2 container apps in your list. If you use the same prefix, I use the AI prefix here. Now, when I click on AI Web UI, you will get information about this container app. So the container app has much more configuration here, and everything that we did in that bicep file should be reflected at this level. The first thing I want to talk about is indeed the fact that we have an ingress here. So the ingress was set to external true, and that means we say we accept traffic from anywhere. And that also means we get a public DNS name linked to the public IP of the environment. So here, if I click on this one, I will go to my app. Let's just try that and open the link in a new tab and see what happens. And I should see that here in the in this one here, the tweet generator. So it opened up the UI here. Let's hope that it works. So let's try again with a Kubernetes joke and a funny one. And yeah, this is still working with a couple of nice icons there as well. So let's go back to the web UI, and that was the ingress part. Now remember, we also configured Dapper. Well, Dapper, of course, is configured here. You can see that. And the Dapper ID we gave was web UI. So that works as well. We also connected a managed identity to our container app, and that's reflected here in the user assigned list. This is our managed identity that we added. Now, if we go a little bit more below, we see also, and that's important, our revision management. When you deploy for the first time, what you should get is already 1 revision. Your first deployment leads to 1 revision, and we're using the single revision mode here. That's the default, by the way. And here you see your deployed revision. You can click on that revision and you can see a couple of its properties over there. Also, if you want to restart for some reason your containers, you can do that here with the restart option. Now, this revision, of course, deployed my containers. The containers can be seen here, but I only have 1 container deployed, although I could have multiple ones. And remember, we are using Azure Container Registry. Well, I'm using now Azure Container Registry, and you see a reference over there. I also use the default container resource allocation. So I get a half of a CPU core and 1 gigabyte of memory. The max here is 2 and the max of memory is 4. Remember, I also configured an environment variable, this invoke URL, that is going to be used by my code to do the Dapper call. For scaling and replicas, I set it to 1, 1. Now, it's interesting here that we can indeed say, well, I want to change this. I want to actually scale to 0 if there's no work being done, and I want to scale up to 2 if there are more requests coming. So let's change that And indeed, I can set my min to 0 and I can set my max to 2. Now, by default, this will do the scaling based on 10 concurrent HTTP requests. But you can modify that by adding a scale rule, naming the rule, and then setting the rule type to HTTP scaling and enter a different number of concurrent requests here. I'm not going to do that. I'm going to accept the default of 10 concurrent requests. Now, be aware that when you set your scaling rules and when you click create here, that something will happen. A new revision for your app will be deployed. And that's, of course, viewable or visible in revision management. Of course, the same will happen if you do this from Bicep, right? If you modify your Bicep code and you're modifying the scaling settings, then of course you will get a similar thing. Here you see now that I have a new revision being provisioned. That shouldn't take that long. Then after a while when I refresh, but sometimes this refresh button is not available, so you have to click away and click again. Then when you click on refresh or the screen is updated, you should see that you have both provisioned for a moment, but then the later revision, so the earlier one, will be removed and will be put at an inactive state. That takes a moment. So if I'm going to refresh a couple of times, now I have my new revision deployed. If I go now to scaling and replicas, I can see indeed that I have the min set to 0 and the max set to 2. Now it could be that my container is now scaled to 0. That means, for example, if I go to the log stream, I might not see anything because it has been scaled down because there are no requests. Now it hasn't done it yet. I can still see at this moment my logs, but after a while, if you do it on your system, after a while you might see indeed, hey, there is nothing to see here because indeed the container is not running. Then just do a call to that URL of our web UI. It will then spin up, right, a cold start of that container, and then you can indeed see the logs again. So that's our web UI. If we go to our other application, you'll see that it's not a big difference. If you go to the API, you'll find that there's not much to see there. That's a big difference. The only thing is that the ingress is different, right? The ingress was now set to not external, but internal. I want the UI to call the API in the backend, but only the UI can reach it on the internal container apps environment. And indeed, you can see that ingress is enabled, but limited to the container apps environment. It's not accepting traffic from anywhere. And of course, Dapper was enabled because my web UI is calling the endpoint on my API using Dapper. For the rest, all the rest is similar, but you do see that my container, my API container, has a couple more environment variables set. So in this case, I have my type set to Azure because I want to use the Azure OpenAI features. I have my key vault set, and I have my grid for my managed identity set. This was set from my Bicep code. You can, for a moment, forget about what you see here, this API environment variable. That's not important right now. In the log stream, you should be able to see that indeed you're getting all kinds of requests. For example, what you can see is a moment ago, I generated this tweet. In my debug logging I'm doing, you will find the complete response of the Azure OpenAI model. And in this case, we're seeing that we're using the text Da Vinci model and that we got a response back in this text field here. And this is the actual full response, the tweet that we extracted in the code. This video is getting kind of long, but we have to finish with a quick look at the Python code. And even if you don't develop in Python, it should be fully understandable because the code is really not that complicated. Remember the web UI, we set an environment variable. We wanted to have this invoke URL for our Dapper call. Well, we check if that environment variable is set, and then we retrieve that environment variable. Then in the code that generates the HTML and so on, what we're going to do is we're going to, once we click on the submit button, we are going to do our request to our backend API. So that's our API, which is using Dapper, of course. That API is on its own then going to call either the Azure AI APIs or the OpenAI APIs. And here we simply use the requests module from Python. We just use that to talk to Dapper directly using the invoke URL that we set. If you look at the Dapper documentation, you can see that you can either interact with Dapper using HTTP APIs. That's what we're doing here. We're just doing HTTP requests to a Dapper sidecar next to our container. Or you can use the Dapper SDK. There's an SDK for Python, and we could use that to do invokes as well. In this case, because I only have to do one invoke, and to demonstrate the use of Dapper, I didn't need to include the full SDK here. So this will do a call to Dapper. It will tell Dapper, hey, you have to call the generate method on the API in the backend, and the API is using a Dapper ID called OpenAI. Dapper will do that call, and if that call is successful, will give us the response. The response will include JSON, and there's a field in the JSON called tweet. We extract that, and then we actually are going to render our template. It's a Jinja template here. The tweet is in there, and that will then show the tweet on the HTML page. Nothing fancy there. We won't go into that. Now, the actual API is in the OpenAPI or OpenAI folder, and there's an app.py there as well. There's a little bit more code in here, but basically what we do here is we have a function that can read a secret from Key Vault. It'll either read the Azure OpenAI key or the OpenAI key to call, of course, the backend AI models. Then we have a couple of environment variables. Remember, I can set the type. The type by default is Azure to use Azure OpenAI, but you can set type to OpenAI to use the OpenAI APIs directly. But in my case, it's set to Azure. And of course, we're checking if we have the Azure Key Vault URL and the Managed Identity Client ID, because we need that to connect to Key Vault. Then we, of course, have to retrieve the keys. So depending on the type, if the type is OpenAI, we set the OpenAI API key, and that's going to be our secret from Key Vault. In our case, the type is set by default to Azure. Then we retrieve the Azure API key using our Key Vault code here, and we log it to the log files. We're saying that we're using Azure. Now remember, our UI is going to call a generate method here. So we have a route, we're using Flask here. We have a route called generate, and we have to do a post to the generate method. And what the generate method is doing is it is going to do a call to either OpenAI or the Azure OpenAI services, depending on the type that was set. So if the type is Azure, we're going to generate the tweet with the generate Azure function. And if we go to the generate Azure function, you'll see that we have some code over here. And just for fun, we actually just use the REST API to do the request to the OpenAI model. So, and that's maybe not so great. I hard-coded the URL to my Azure OpenAI instance directly in the code. That's not too bad, but it should be configurable. We just do a request, and we give it a payload, basically, that we created here. And here, of course, is where the, let's say, magic happens. The prompt that you give the model, and the prompt that I'm using is a very simple prompt. We cannot call this prompt engineering. We just say, hey, write a tweet about text. That's what we filled in into the text box, and make it sentiment. So if we select Kubernetes and funny, we have write a tweet about Kubernetes and make it funny. That's my prompt. I set the temperature a little bit higher to have some more, let's say, creativity in the response, but that's the payload I'm sending to the OpenAI model. So there you see that when I do the request to the OpenAI model, the payload is what we created above. Of course, in the headers, I have to authenticate, and I'm setting the API key as a header there. Then from the response, we are going to extract basically from the response from the model, we're going to extract from choices the first choice, because we only have set to respond once, and we just select the text there. And that's the tweet. So then we return the tweet from there. Now, I told you a moment ago that to generate a response with Azure OpenAI, we use the Azure REST API for fun, so to speak. With the Azure REST API, what happens, we're doing a call to our OpenAI instance. And because we configured a model in that instance and we call that model tweeter, that model was configured to use the Text DaVinci 003 model. And then we say we want to use the completion API for that model, right? This is how the REST API works. Now, if you have done some work with the OpenAI SDK for Python, you'll see that it is a little bit more complicated, this thing here. So what if you want to use the OpenAI SDK? And by the way, you can find an example of the OpenAI SDK use in the generate OpenAI function. There indeed, we use the OpenAI completion API where we say, okay, give me a completion to a prompt. The prompt is the same as we did before, write a tweet about and so on. And then we say, okay, the prompt is this, the model is this, and so on and so on. And that generates a tweet as well. But you don't have to do a REST API call here. It's just built into that OpenAI SDK. Now you can use the same OpenAI SDK with Azure as well. So I didn't do that. I used the REST API. But if you want to use the Azure or the OpenAI SDK with Azure, you just have to go to this article here. And there you'll see, if you go a little bit below there, that you can set in your call, you can set certain values to say, okay, what is the base? Well, the base is then the Azure endpoint. The type can be indeed set to Azure, and the API version, which should be this, can be set from there as well. And then you can use the same OpenAI SDK in Python with the Azure OpenAI services. We've come to the end of this rather long video, so thank you for sticking with it so long. I hope you liked it. Be sure to include or look at the README file in our Git repository because it contains additional information on how to update your container apps using workflows or GitHub workflows. If you have any questions, drop me a comment and see you next time. Bye-bye.